Hi everyone, my name is Sarthak and I work as an SC2 in Dunzo and I'm also part of Recro, which is a developer focused organization where we are trying to connect developers' aspiration to the right opportunity by working with high growth startups such as Dunzo, Swiggy, Curefit, Udan, and a lot more similar startups. So today we have Hitesh Das, who is an Android enthusiast and having a 10 plus years of hands-on experience in mobile application development. Currently, he leads the Mobile Android Guild at the OLX Group, mentoring and managing to work together to create the environment of curiosity, encouragement, and technical growth. He loves to cook, read, write blogs, listen to music, and meet and interact with new people across the globe. Hitesh is also passionate about giving back to the developer community, as it is not only makes a positive impact on the lives of others, but also enables others to maximize the fulfilling experience of giving back. Today, Hitesh will be giving us a talk on progressing towards responsible software craftsmanship, which will include how to approach the software development process and what are the best practices that we should use during the development cycle. So uh, I'll hand over this session to Hitesh.
Thank you very much, Sarthak, for the brief introduction.
Yeah.
And yeah, thank you, Recro, for hosting this event. Welcome, guys. Good afternoon. Myself, Hitesh. I am currently the technical architect leading the Android team at OLX Group from Gurgaon. And yes, I have been passionate about development into mobile development. I'm into almost into the mobile development almost close to 10 years. Yeah, even more than that. So today's talk is something that will tell you about a journey towards software craftsmanship. So before starting any going further, can I ask the audience how many of you are aware of this word software craftsmanship? I got 38% of people audience who are aware of this word software craftsman, and 62%, yeah, now it's almost like 50-50 audience. Yeah, I think it's a perfect match to have this session, and probably those who are very much aware of this term and probably the movement, they would have a fair chance of revisiting all those principles and manifestos. And for all the ones who are basically new to this term, probably they will also learn how you can progress towards a responsible software craftsmanship, and also how can you apply those principles as well as best practices to your day-to-day development. So guys, when the word craftsman basically comes to our mind, like what kind of thoughts that you have, basically what kind of thoughts do you get? So ideally, what comes to my mind, or probably most of one of us will agree that it's ideally a sculptor. That is basically the backdrop of the very first slide, intro slide, that title slide that I'm presenting right now. Ideally, when we heard the word craftsman, we see a person who is basically designing some craft, or probably a potter who is designing a pottery or something like that. But if I talk about software craftsman, it's very equally likely that we'll be visualizing or probably imagining someone writing code, right? Because code that is basically a well crafted code. Let me tell you the reason behind this. So the reason behind this is all those softwares that we develop, they are basically judged on the basis of their utility, and all the materialistic thing, like for example, let's say a potter designing a pot, or probably a sculptor designing any kind of craft, that is basically valued in terms of the aesthetic beauty, the outer beauty of the product, right? So a software, if I say, it's deemed to be great if it solves the problem of the customer, and that too in a best possible way. So going forward, so what does software craftsmanship say? So software craftsmanship is about professionalism in software development. So a lot of guys are basically when it started, the movement started basically in the 2000, when people started talking about this, and it came from actually the Agile manifesto that we follow. Like, most of on us would have been into this kind of atmosphere where we practice Agile, right? Now, the biggest problem, or probably the biggest challenge of Agile, is basically what happens is, like, when it comes to delivery, what you do is basically eliminate some of the practices, right? So often what we do is basically we shift our frame from excellence towards mediocrity. So the software craftsmanship movement is basically all about marrying, or basically coupling, the practice and the culture. So the culture of Agile, that is basically delivery oriented, and the, you can say, the practice that comes from the best practices, or probably the god of software, like, industry. So basically those practices and the culture, software craftsmanship is something that basically is responsible for marrying the two. So software professionalism is about professionalism in software development. Now, in the heart of every software, there lies some customer need, right? So, and that needs, you can term it as a business problem. So the success of every software project is the conjugation of those customer problem, customer basically the satisfaction, and the elegancy that your software basically projects. So the software is basically deemed to be great when we have a very user-friendly software. We have a very robust, a fast software, a secure, stable, reliable, scalable, as well as maintainable. Now, when it comes to scalability and maintainability, one thing that comes to our mind is basically the well-crafted software. So if the software is not well-crafted, obviously it's gonna be a very hard piece of code to maintain in near future. So why are we discussing this today? Why is it the need of the hour? Now, the next slide will be very much relevant to you. Is basically whenever we discuss among ourselves, or probably we listen to different podcasts, or probably different experts, like, commenting on, like, the software fail mechanism. So basically we hear three terms majorly. One is basically the poor planning. Second, the poor requirements, and third is the poor management. Now, the problem is that nobody talks about uncontrolled complexity, because a software can be a disaster if the complexity of the software is uncontrolled. So it leaves us with what is called technical debt. Now, if I define technical debt, is like something that we generally develop in a very, you can say, fast manner, or probably to meet the delivery deadlines, and probably we compromise. Remember, we usually used to shift from, like, excellence to the mediocrity. So when we shift from excellence towards the mediocrity, there is a technical gap, and that technical gap basically piles up to be your technical debt. Every best possible team in the world, they have a technical debt. So when the technical debt grows, even it gives you the more impression that, yeah, it needs to be like, overcome, right? Now, with the piling of technical debt, what is the problem? If we don't pay notice to the uncontrolled complexity, so the main problem that we have is basically lots of defects, right? Because our software is not well crafted, and there is no any kind of feedback loop. So I'll tell you what exactly the feedback loops synonym basically matters in software industry. So there will be a lot of defects. Secondly, the code will be less reused. Third, there will be a lot of rewrites, right? Because you'll be seeing, whenever your software, basically there is a lot of developers in a development pool, they will basically end up rewriting every possible stuff that has been written probably a project before. So even if you don't control if you don't control the complexity, rewrites is meant to happen. Fourth, increase development times. So what do you mean by increase development times? As in, let's suppose a project was delivered in a sprint time. I'm considering 2 weeks as a sprint, and we have some technical debt, and that is basically a known technical debt. We compromised excellence to a mediocrity because of the delivery timeline, and because of that, like, we have some technical debt piling up. Now, one thing that is very constant in the software industry is basically change. Requirements change, and always there will expect a change. So basically there will be change, to the existing product, or probably there will be change in the related product to your software. Now, what happens is, like, whenever you're delivering a particular project in a sprint time, probably the next time the product manager comes to you and they ask for an incremental change over that project, that development time will increase. So basically now, probably if you have estimated that you will be able to deliver in a week's time, the product manager, or probably the client, in this case your company, they will assume that, yeah, they have built this product very fast in a sprint time. Probably the next incremental change will basically require a week's time. But in reality, what happens is, like, if you have a very huge technical debt or probably some uncontrolled dependency, the development time has been seen increasing. So this is something that is well proved, and most of the teams in the world are basically concerned about this. Like, I delivered something, what about incremental deliveries? So we'll talk about this, how we can reduce that effort. So for now, and the most important thing is basically afraid to change. So what happens, a new developer joins your team and he is basically given that sheet of project or probably technical debt. So it will be very much afraid to change, right? So whenever something, there will be close dependency, like someone developed that code and probably that person is not present, and probably you have a lot of technical debt, and also like incremental changes are taking time, there is no reuse, he can't reuse your code, and there are lots of defects. Obviously there will be a chaotic environment where your code, nobody will go and basically touch your code. As I told, software change is inevitable, so you can't restrict software. If one requirement is coming, then probably the second is almost next to your door. Now we talk about the introduction. We know about software craftsmanship, like it's a kind of professionalism in software development, why we need a software craftsman, or probably the why we need a software craftsman mindset. Now, how we will build that mindset within us as a software developer? Because at the very beginning, I would have said that softwares are not laborers. So we need to be that professional enough to call ourselves software, and also to develop that craftsmanship mind, so that we can have a software that basically scales, that is fast, that is basically maintainable, and people don't basically afraid of taking download from our code. So how to build that craftsmanship mindset? So the software craftsmanship manifesto, they basically laid 4 dimensions of quality. So if you practice software craftsmanship, these 4 dimensions of quality should be inside you. So basically this should be in your head. Number 1, not only working software, but a well crafted one. So what does it suggest? Whenever you write a code, do support with test. So you remember I told you the feedback loop thing, right? So who will give the feedback loop? Your test cases will give you a feedback loop. So whenever you change something, whenever you write something, there is a supporting test suite that gives you a instant feedback just by the click of a button. Code should speak the business language. I have seen a lot of softwares in my 10 years development, more than 10 years of development, where whenever looking at the code, it's very difficult to know what the code is doing. So whenever you basically write a code, then the code should speak the business language as in the customer requirement. So let's suppose I have a requirement from a customer who says I want a printing software that prints a paper for me. So basically when you are writing the code, you should keep in mind that yes, that piece of code is basically meant to solve a printing logic. So your code should speak the logic of the business. It should speak the business language. The design should be simple, and it's not like, if it should not be that much simple that you radially shift towards no design. It should be simple in the sense that you should not build something which you don't need it. So stick to the basics. And the first manifesto we read is basically, it's not only working software but a well crafted software. Going to the second, not only responding to change, but also steadily adding value. So there is a Boy Scout rule, like always leave the campground cleaner than you found it. So what does it say? Let's suppose I developed a software. In my earlier example I gave you, right? Whenever there is a new change, probably it takes a lot of time. So what happens is, like, you develop the piece of code, and after few weeks, your product manager comes and say, hey, I want to add this feature on the top of the existing feature. Now let's suppose you want to delegate these to your fellow developer, and that developer basically opens up your code and he sees that, yeah, I can't reuse it. The classes are non extendable, and even if I give the maximum effort, I can't optimize it. So it's a kind of nightmare for him, right? So that's why there is a Boy Scout rule. And Uncle Bob, if most of one might have, heard his name. So he has mentioned in his book. So always leave the campground. It's a Boy Scout rule that always leave the campground cleaner than you found it. So whenever you go and basically write something, write in a way that someone who is like you know who will going to maintain that particular code, will maintain a particular in the future, he founds the ground cleaner. So code that should write should be testable, it should be extendable for incremental value addition, and refactoring for optimization. So basically there should be a chance of refactor. It's not like you write a code and you just forget for years. No, you should be able to refactor the code and not rewrite. You should be able to refactor the code, probably for optimization. So when you think that there is a chance of optimization, there is a chance of refactor. So we complete the second manifesto. Going to the third: not only individuals and interactions, but also a community of professionals. So what software craftsmanship entertains is basically people who have the mindset of sharing and mentoring, and also sharing knowledge, not only within themselves or probably with individuals, but yeah, with a community. So discuss and propose ideas, share success and failures, community engagements, and inspire and ignite the same passion with the peers. So whenever you meet someone, probably it's not like learning something and keeping it to you. You should have the mindset of sharing with the community, probably, and also probably with your immediate peers, and also to a wider audience. So this is something that software craftsmanship cherish. Going to the last: not only customer collaboration, but also productive partnership. So customer has got a very wide audience, right? For software developers, your immediate manager could be a customer, or probably your client, or probably your company, or probably the end users could be a customer. So what the software craftsmanship says is basically, whenever you are writing a software, begin with a mindset that you're going to help your clients. And also you should not be afraid of saying no for clients benefit. So it's not like you just say no to everything that comes from a customer, but yeah, you should say no in the sense that, yeah, this is not the right way that we should do it, and this is the best way, so that we can give incremental satisfaction to the customer in terms of deliveries. So you should be ever ready with those answers. Cultivate productivity and partnerships, finding a way to ensure engagement quality. So this is what the engagement quality means. So basically, whenever you're delivering something to a customer, probably that customer finds it very interesting, they gives you feedback, probably you implement that feedback, and probably you analyze on that feedback and probably come with a better solution. So these are the four manifestos of software craftsmanship. So if somebody wants to cherish, or somebody want to practice software craftsmanship, these four principles, these four manifestos should be in their minds, should be in their mind. First is basically the well-crafted software. Second, you should be able to incrementally add value. Third is basically the sharing with the community. And fourth is basically the productive partnership with the customers. Now, how to progress? Now we know, yeah, these are some of the bookish, you can say, language, or probably someone has laid the manifesto and they want it to practice. And so, what are different tools or probably mechanism with which we can progress in that mindset? So, I will walk you through some of the uh, tools and also practices that basically will help you in deciding or probably sticking to the mindset or probably the manifesto, the four manifesto of software craftsmanship. Number one, application architecture. So application architecture is one of the backbone of your software. Like whenever you're building something, and if that is not supported by the architecture, that is going to be, you can say, disaster, probably a dead end at the very last, in terms of the requirements that comes on, like very frequently, and you don't have that bandwidth to remove the technical depth from you. Probably architecture is something that will give you a nudge towards that, the craftsmanship mindset, where you will be able to decide that yes, this is something where I can take the trade-off, like in terms of shifting the gear from mediocrity towards excellence. So if our application is based on architecture, a good architecture, probably the best suited architecture for a business problem, then probably in the later stage you will have a good chance of refactoring, also managing the technical debt, and also helping the peers to understand, and basically your team speaks the same language. So why it is so important, as I told, is the primary element of the design and planning phase of your software development. And without the software, it's like, no, the bigger the building grows, the more problems this will cause. So whenever your foundation is very much weak, probably whenever you go higher up in the floors, your building will shake. So that is something, a simile that you can draw, why architecture is basically important in your software development. I've seen very I've seen lot some of the applications where they don't follow any kind of architecture. They have a monolith and probably writing everything in one place, and that application works like charm. Like people, I have seen people telling, that our application is working even with a monolith. So why should I go for that? It's not like good or bad. It's basically use case to use case. It will depend. Probably now you are feeling that, yeah, my monolith is working very fast, and probably it is not having any problem. Why should I refactor my entire code to a particular architecture, or probably to a new architecture? Now when you see, if you talk about software development, we're doing this for one major reason, basically the fast, like how fast you can deliver. So in a monolith, and also fast as you deliver, and also without breaking unrelated stuff. So it's not like in monolith, like when writing everything in one place, changing a particular requirement probably might impact others. So these kind of things will basically increase bugs, increase defects, increase development time, and increase the testing cycle. So this is where your return on investment, you can see, if you invest right now on architecture at the very starting, probably you can see the returns in near future. So this is why architecture is very important. So this is the one graph you can see, where I have compared the technical type with respect to time. So if you allow your technical debt to grow, the x-axis represent the time, and the y basically the technical debt. So what happens is, like, the below line is basically, you're building a software with a software craftsmanship mindset, where you are taking care of those uncontrolled complexity, and the above one is basically the one where you are basically shifting your gears from excellence towards mediocrity, or probably even lower that. So what happens is, like, whenever the requirement comes from your client at the very outset, even the fully architectured, fully, practiced, best practice followed, architecture, or probably the project will see a very minor, change, basically the change that comes will be very easy. So in terms of monetary, if I want to compare, let's suppose we give a value to it, let's suppose $1. So $1. So basically what happens is, whenever there is a change, the one who is basically a software craftsman, and one who is basically a kind of software developer who is basically unaware of the practices, and probably they don't have any architecture, probably you will say, yeah, it's very sunshine to me, it's okay, I can do it in this much amount of money, or probably time. As you go further, you will say change is hard. So that person will say, yeah, the change is hard, this is costing me $10 now. Whereas if you see the refactor code has got a pattern. So what happens is, like, whenever the technical debt grows, at some point of time in near future, you will find that people saying, yeah, change, oh, come on, forget it, I can't do it, I need to revamp the entire application. So this is where the architecture, the importance of architecture comes into picture. Like, if you have started the project with a very base, well based, architecture, this problem wouldn't have occurred. So along with the increased size and complexity of the project, these problems actually accumulate, and finally it's a dead end. So because of this, architecture is very much important, and we should stick to a particular architecture. So what are the characteristics of a good design? So if I am to tell the characteristics of a good design, number one is the minimum complexity. So minimum complexity as in your code should be maintainable. Maintainable as in separation of concern. The code should be dealing with one particular a single class should deal with a single problem statement, or probably the single responsibility principle. Totally, I'm talking about. Second is the ease of maintenance. Again, single responsibility principle, probably how much easily you have that feedback loop with you, how many unit tests are covered, and probably how well you can maintain and probably increment your features. Third, loose coupling. So whenever there will be separation of concern, there will obviously be a loose coupling. So your components are basically independent, and you can individually test your components in isolation. So this is what called loose coupling. Second is the high cohesion. So there is a very important term, cohesion, how cohesive your code should be. So in a very simple terms, or probably if I talk about a beginner term, cohesion is something that is all related places in one place. So there is basically a single source of truth. If a particular system fails, let's suppose if an order management system fails, I directly go to the order management software, not to the tracking software, or probably I won't go to the payment software, or probably I won't have a scope of basically the problem extend beyond my order management system. So this is what, keeping your code more cohesive means. And definitely, we should not build fighter jets to buy groceries from the mart on the opposite road. The first principle, the design should be simple, but there should be design. It's not like, you are building fighter jets to go to the groceries just to have a simple use case solved. You are building hell lot of classes. You are defining very much, quantitatively you are just putting up stuff, but yeah, the use case is very small. So you need to have that feedback loop also within yourself. You should be able to judge whether I should go with this architecture or probably that, and that could basically be simplistic. And remember the four design principles, right? So it should be minimum complexity, ease of maintenance, loose coupling, high cohesion. You are fine. Moving ahead, so there are different levels of design for all those who are basically new, since the session is basically comprises of both beginners to advanced. So whenever you find a particular problem, so what you do, you basically divide into different subsystem, or probably if you talk about the project structure, you divide it into different packages. Third is basically division of the classes within packages. So what happens, you have a package, and inside that you see, hey, this package holds this amount of classes. Let's break it. You break those into different classes from a single software system. You divide it into subsystem. After subsystem, you go into packages. Within packages, you divide it into class. In every class you have different routines as in you have different delegation, right? Because a single class can delegate multiple stuff to different classes, not like consuming every use case within a single class. So this is how you basically design a particular problem statement. So whenever you get a problem statement, just break it into such a molecular level that your code is something that executes, or probably that code is well enough to be tested in isolation, and the separation of concern is maintained, and the bounded context is maintained. What I mean by bounded context is basically the, as I given the example of the order management system, if there is a problem in the orders, you probably go to the order management system, not to the payment system. So this is how I have been following, and also I have mentored many of the guys, even if you are not aware of the best practices, even if you're not aware of the architectural guidelines, probably have a kind of snapshot of this in your mind. Whenever you have a problem, break it in this levels of design. This will really definitely going to help, and yeah, I have seen people getting help from this kind of approach. So I'll give you a brief overview of common architectural patterns. I think most of one will be aware of all those patterns and the architectures. But yeah, for all the beginner ones, probably I want to give you just a brief overview of the commonly prevalent architectural patterns that you will see in all the applications, both in common applications and also the enterprise applications. First is basically the layered architecture. Second, event driven architecture, and third is the microservice architecture. So layered architecture, I will take one by one, and probably we as you go further you will be knowing how what are event driven and probably the microservice architecture. So layered architecture is basically, as the name suggests, it's a kind of layering, so where you layer your software into different levels, or probably I will say roles, where you assign different roles to different layers. So what you get, what you achieve after dividing your software into different layers. Number one, it's maintainable because the separation of concern is there. Second, each layer can be tested separately, it's testable. And third, easy to assign separate roles because it's very clear, and the boundaries are defined, right? You can say the gray dotted line, the boundaries are defined, and also the dependencies are also defined in such a way that yeah, the presentation layer should be directly accessing the business logic layer, and the business logic layer data layer, and presentation layer should not know about anything about the data source or probably something like that. But yeah, so this is something that is easy to update and enhance layers, and easy to adopt because this is something which can be most of the IDEs supports. Like you can easily adopt this architecture, and you can easily define roles to different layers. So this is how we see the layering architecture. This is basically something that comes from clean architecture. So all those who are aware of clean architecture, they might have been, they might have have a cleaner picture of this about the onion architecture, hexagonal architecture, and all this stuff. But yeah, if you talk about in a nutshell, your entire clean architecture, or probably the architecture or the layered architecture, is basically divided into three layers. One is the presentation layer, and second is the domain layer, third is the data layer. So presentation layer and data layer are basically platform dependent. So presentation can be, if I talk about mobile applications, let's call Android. So presentation layer will be your UI, data layer can be your database, probably your network, probably your retrofit client, anything. So it could be your anything. So basically the outermost layer, that is the data layer and the presentation layer, basically depends on your innermost layer. So basically the dependencies moves inwards. So domain layer is something that is basically independent. And what does domain layer consist of? So domain layer consists of three different things. One is basically the business objects, like a real business objects. Let's if you call about your order management system, probably a particular order could be a kind of business object, right? A user can be a business object, and the manipulations on that business object is basically the domains, business logic. So the business logic, a domain layer consists of the business objects. Second is the business logic, and third is the domain service. So basically what will happen is, whenever you are going to manipulate your domain objects, you will be needing help of some service that will basically fetch data from some repo, or probably it will manipulate something, it will get something from the database or something like that. So your domain layer is basically further divided into three categories. One is basically the domain objects that speaks about the domain model. Remember one thing, your software should talk business. So basically whenever there is a requirement and people comes with you, you should be able to identify, yeah, these are my business objects, and this objects can be in the domain layer. So they will be in the domain layer. There are another objects, basically you can define different, as you can see there are different mappers, right? So these mappers are basically, you can say, mappers from one object to another. So what does presentation mapper does to the left? It basically maps the domain objects to the presentation object, to the view objects. So there can be different mappers, but if you talk about the dependency of those layers, the outer layer basically depends on the innermost layer. So innermost layer can exist in isolation. So ideally you will see the domain layer is platform independent. So you will not find, if you talk about mobile or probably enterprise application, your domain layer will be a simple plain old Java or probably Kotlin or probably whatever you use in a native language. So it will be a native piece of code, and your data and presentation will change very much, but yeah, your domain layer will be constant based on a particular business use case. So now we have got a fair understanding about the layered architecture, where we have divided our entire project into three different layers: presentation, domain, and the data layer. Now it's time we go deep into the event driven architecture. So what does event driven architecture says? As the name suggests, event is something that happens, right? So in most of the applications, or probably in most of the enterprise projects in the software, you will see that programs, or probably the piece of code is basically waiting for something to happen, right? So basically an event. Now, for example, let's say in order, let's suppose you are placing some order in Amazon, or probably in some kind of shopping app. So what happens is, like, you initiate a request, you load your cart, and somebody at the cart is basically calculating the price, probably calculating the discount, or probably you have applied some code, discount code someone is calculating, and probably by the time you basically place an order, what happens is, like, the order goes out of the stock, and you basically get a email in your, or probably a message in your, or probably a notification in your app, like, yeah, hey, your product is out of stock. Now if you can imagine, like, if you talk about the entire flow, user coming to the cart and adding a particular product, the product basically says, yeah, this much discount is possible, then again it's checking the inventory and probably throwing a mail. So if you can visualize, all this system are basically waiting for some triggers, right? So the cart is waiting for something to be added, right? So when something is added, what happens is, like, the price engine basically, or probably the discount engine, runs automatically. It suggests a particular price, or probably the best price, or probably the coupon codes. And whenever you are basically placing an order, the inventory checking mechanism is waiting for that event, right? So whenever you're placing the place now button, is basically waiting for that place now button. And whenever that intent is basically arrived, or probably your inventory management system basically receives that particular intent, what it does, it checks the order, and then it finds that, hey, it's out of stock. And then what happens is, like, your email delivery mechanism is waiting for the event about the no stock event, right? So whenever there is a no stock, send a notification. So if you can think of this, like, it's a kind of specially true, this architecture is specially true for systems that work directly with humans. So whenever there is a user, whenever there is a kind of user, or I would say, even if it's not an user, even if you talk about the CPU, or probably whenever you are pressing the power button of your laptop, or probably your system, it's a kind of event driven mechanism, right? So your user, I would basically consider the system as a user in this case. So whenever there is a user, you can think of event driven mechanism. Now what are the benefits of event driven mechanism? It's adaptable to complex, even chaotic environments. So you see, the order management system is something is very chaotic, right? So you can think of everything as an event. Now when I tell you about the events, now you might have been thinking, yeah, so now you can visualize the entire picture. So everything, like the Iron Man in your Avengers, like, so things are moving here and there. Yeah, so if you can visualize that particular stuff, you are in a right direction. So probably you can go and adapt event driven architecture. They are easily extendable whenever new event type appears. So whenever you want to add some new event to your system, so they are easily extendable. You can just add a new event, and probably you can register a particular event, and probably register your new component to that particular event. When that event will occur, your system will probably get a notification. So this is something that is event-driven architecture. So in event-driven architecture, we'll find three main categories. One is basically who produces the event. Second is basically who ingests the event, and third are the consumers. So these three, you can say, entities, you will find while you will be designing your event-driven architecture in your next project. So event producer will produce the event, somebody will ingest the event, and finally the consumer. So you can compare this to the observer pattern pub/sub model that basically handles all those observable pattern and all this stuff. Yeah. So there is one more very famous architecture, and probably people are adopting it very frequently in across all levels of expertise, not only mobile, probably enterprise application, back end, front end. So it's called a microservice, or probably the service oriented. So it has got different names. Somebody call it service oriented, somebody call it microservice, somebody call it microkernel, it's somebody call it plugin based architecture. So there are different names to it, but the idea of service oriented architecture is basically there will be a single unit, and every unit will basically have been like your single unit, basically every feature will basically plug to your single unit. So if there is an application, that application will basically be plugged by different systems. Let's suppose the user profile system, there is a setting system, there is a core functionality, there is a video player functionality, and these are all separated. So these are all separated as in they are built as a separate module and plugged into the system. So if you can visualize, these are something, if you say a plug and play, that plug, it's similar kind of like you're plugging your phone with a different charger. So basically your charger is the feature and you're plugging it to your phone. So what happens is like you have a lot of features, and those features are basically used at runtime or probably reused. So this kind of architecture, when you will go for this kind of architecture, so whenever you see that there is platform independence, you need to achieve platform independence, and those features can be exist in isolation. You can go with a service oriented architecture. If you they are easier to test because everything is different and they don't have any kind of platform. You can build it a platform dependent or probably a platform agnostic feature. They are easier to test and more reliable. Ability to reuse the codes, definitely. If you feel like yeah, this particular, let's suppose the discount mechanism, right? So let's suppose I have a discount engine that basically runs on a particular product. It takes the input as a let's suppose the discount codes, and probably it applies to the particular product. So this kind of common business problems can be used across all the, you can say, across all the uh, that thing, your apps, right, your system. So this kind of things can be used in a very effective manner, and you can reuse codes wherever possible. Parallel development is also possible with service oriented architecture, because whenever you are basically taking up a business project, and in that business project demands different feature sets, probably each feature sets can be developed in isolation with a team, and they can execute it in parallel towards the delivery. And whenever that is done, probably you can plug it into the app and your system is up and running. Scalability. So scalability is something that is there because each individual component can scale on its own. So if you talk about deployment, every feature is itself kind of can be self deployed. So it's not like that there is a change in particular one of the microservice and probably the application, entire application needs to be deployed, which is not same in terms of layered architecture, because in layered architecture everything is related, and in service oriented you have the power to ship a particular module independent of the app release cycle. So when you will go with her, because I have seen a lot of people like whenever they get to know about the microservice architecture, they feel very excited, and what they do is like they design their application as microservice. So everything is segregated, and there is a different repo for everything. So the major clue while to decide on a service oriented architecture is basically the vision. So if you have a vision that your system will grow, and at some point of time your system will be bulky and you will be supporting a lot of features, then you can think of a service oriented architecture, building different components as in isolation. You can, if you think of yes, I need to deploy my application every now and then, and a very small change to a particular feature, my entire application release cycle, basically testing the sanity of the entire app is very difficult, then you can go with the service oriented architecture, because you'll be shipping those newer modules, and those are basically app release independent. So likewise, you can have kind of decision making, whether you want to go with service oriented or event, or probably the layered architecture. Now we have discussed about the craftsmanship mindset, and we have been progressing towards learning about different architecture. Now, what's the motivation? Like, you know about all this architecture, or even there are a lot of architectural patterns, right, evolving daily. So what should be the motivation? Because architecture come, architecture goes, right? We are not using MVC right now. Most of the people are sticking to MVC because it's fulfilling their needs. But what should be the motivation? Cost. So cost is one of the motivation in terms of the maintenance, like how easy to maintain, how many people is in your team, or probably how equipped are they with the tools. Time to market, so how frequently you release, that will again depend on, like, one of the key factor, how big is your app, and probably how many features is your app supporting. So these kind of things will basically matter while choosing your architecture. Number of users, current and future, so at what scale your application needs to be deployed, that will also depend on the architectural decisions. Level of independence, so if you're building a software, how independent it can behave, and how you can, is there a scope of a product that can be integrated to other system, then obviously you should go with a microservice architecture. There is one more hybrid architecture, because event-driven architecture, as you can see, every component is is built as isolated. So you can find a hybrid architecture as well, that comprises of event-driven as well as microservice. So the order management system example that I told you is basically amalgamation of your the event-driven architecture and also a microservice architecture. And within the particular, you can say, the microservice, you can have different set of you can have the layered architecture as well. So nowadays, which I prefer is basically a mix of event-driven along with microservice, and within that microservice we have the layered architecture, and that we follow the clean architecture. Now we have gone through the architecture, craftsmanship mindset. Yeah, we are gradually progressing towards it. I know the practices, I know the architectures now. Then now if you talk about defining the architecture, or probably having a decision making of a particular architecture, so there are some principles as well as some tools that will help you in defining the architecture. So architecture, as well as, how can you basically craft your software in a better way, and basically sticking to the basics. So even if you are very much confused about, which architecture to choose from, and right now I'm not having a particular mindset to basically design, what should I do? Key principles, you should stick to solid principles. So solid principles, what does it say? We have almost covered one of one and the second, first and the second part of it, because every part that you develop should be doing only one stuff. It's a single responsibility principle. If the discount engine is basically to calculate the discount, it should calculate the discount. It should not check the inventory, or it should not check the user eligibility, whether he is a logged in user or probably something like that. So that is a responsibility of the user repository, or probably the user component. So single responsibility principle is something that you should always claim for, and I'll tell you why after I finish all these terms. Open close principles, so as I told you, incremental softwares are always there. People come, people go, requirements come, requirement goes, right? So whenever requirement comes, your requirement should be delivered to the customers in the best possible way, and also in a way where the next iteration of that feature probably should take less time. So always keep that ground clean, so that new features can easily extend your particular class and probably reuse. Liskov substitution principle says that if you are having a subclass, and probably I will give you a very real life example. Like, let's suppose there is a guy, let's suppose there is a son of a teacher, and he wants to replace his dad. Now what happens is, like, later on, what happens when he was allowed to go into the school to teach the students, probably he was talking recipes. So what ended up was basically uh, a class should not basically the son of the teacher was not able to replace his father, right? So what happens is like basically your subclass should be replaceable, should replace your parent class. So this is what your basically the Liskov substitution principle says. Interface segregation principle is again the word segregation. So basically, whenever you design your interfaces of such a way that related interfaces remains in one place, and unrelated interfaces basically either extends that particular interface, the common interface, or probably it's a kind of independent interface. So this is what interface designing principle says. Dependency inversion. So dependency inversion is basically higher modules should not depend on lower modules directly. It should depend on abstraction. So what happens is like, let's suppose I want some data, right? So what happens is like my application wants, let's suppose the user data, and the user data might be stored in, let's suppose a DB or probably a network. Now I directly should not have a dependency on my network. So what happens is like when I have a directly dependency on my network, what happens is basically whenever the network layer change, my system will collapse, or probably I will have to refactor the system whenever I am changing the network. So what happens is like always introduce abstractions. So my system should call an abstraction or an interface, and that interface should be implemented by uh, the outer layer. So remember that presentation, domain, and data. So if the presentation asks the domain for a particular data, the domain should not directly call the data. It should directly call an interface, and that interface should be implemented by the data. So likewise, what you do is basically allow the system to grow and scale in terms of the data thing, like the data layer thing. So whenever you are trying to change the data, so probably your data layer, probably you are not affecting your domain layer. So your domain layer and the presentation layer remains intact. You just change the uh, data layer. So this is what the dependency inversion principle tells. Dry. So dry principle is also very important, because we already took this in earlier slides when we show you the levels of design. So basically dry principle says do not repeat yourself. So what it says is like whenever you are writing a particular logic, and don't rewrite that logic. So if you rewrite, what will happen if there is a error in particular in that logic, you need to change it to two system, right? So there is one system and there is another system, and there are copy of the same logic. So if there is a bug in one system, your other system will also get affected. So why not have a kind of core at the top of it? You move your code, you move your common logic in one place and write it once and reuse it everywhere. And also, less code is always good. It is less buggy. The code coverage looks nice. So yeah, so there is one solid. We learn about dry. There is another principle called KISS, keep it simple. So it's also in the first principle of software craftsmanship, where we say keep your design simple. So you should not be writing lots of code. Your code should be simple. Your method, if your method contains lot of conditions, move it, delegate to a class, and probably your method should never be more than 40 to 50 lines. So these are some of the standard guidelines that you will find, right? So we know about solid, that is basically the 5 principle. We know about dry, that says about we should not repeat our code. Third is the kiss is basically keep it simple. All the design should be simple. Also, we need to have a straightforward, like your function should be doing that stuff that it needs. The food being like Yagni. So Yagni, it says you aren't gonna need it. So you aren't going to need it. So basically, you should not build something that you don't need it. So if your customer says, I want a printer of, let's suppose I want a printer. So you should not be writing code for a scanner, right? Along with a printer. So this is simple as, if you don't gonna need it, don't build it. So it's mostly relevant to agile software teams, and you will find it everywhere, applicable to software craftsmanship as well, because we don't write lots of code, we write quality code, and we write it for the customer need. There are few key practices which will help you to stick to that particular principles that we just ended up, like dry, yagni, and probably kiss. And number one being pair programming. So pair programming, most of the guys or probably programmers in current industry. So although this is quite popular outside India, and also India also, we see a lot of people are into this. But what is the main problem with pair programming is this. So what happens is like we have our own egos, and people is like, yeah, I know this the and mostly I've seen pair programming ending up into indentation, probably naming convention. Yeah, naming convention is something that should be taken care of, but yeah, it should not be like, two people are fighting. So one thing that you can observe in the image to your left is basically there is there you will never find I, right? So it's like, how do we, what should we, how can we? So pair programming is all about we. So whenever you sit together, you should respect one another, and probably you should help other as well. In not terms of criticism is good, but that should be constructive. So pair programming can help you in sticking to the mindset of software craftsman. Pair with a software craftsman, pair with anybody, that will obviously help you. So what I have learned is like, whenever you do a pair programming, you always learn new things. So instead of learning it alone, you're basically learning together, and also you have the scope of others to do the same. So pair programming can help you in that. Practicing dojo katas. So dojo kata is it basically come from all those martial arts and all this stuff. So in dojo kata, let me tell you, for all those who are very much new to this term, so probably dojo kata is something that there is a round table, and every developer sits in a round table in a clockwise or probably anti-clockwise, how you say. So basically there is a mentor, and that mentor basically revolves around the table, helping each other individual where they're stuck. And there is a timer to the right, you can see. So every 5 minutes people will have their turn, or probably how I prefer to do dojo kata is basically having a single system. So if you have a basically handful of developers, single system, revolve the system in the roundtable fashion. And at the end, when you get your own system, probably you will see that a lot of change has been done to your code, or probably you learn something new, or probably you have better idea to implement the same. So this is how the dojo kata happens, and I have been practicing this in my current organization, where we pick up some small problem, very small problem, probably solvable in an hour or half an hour, or probably in a two. So we circulate our systems, and probably we used to do this kind of dojo katas. So typical thing that we do is basically solving some small problems, and within that problem we used to see how we can apply those solid principles, how we can apply dry, how we can apply keys, how we can apply agni. So all these things we can learn while we do dojo katas. Okay, so coming to the last part, the triangulation. I think it's a very debatable topic. The triangulation is the basically the test driven development that comes with the test driven development basically lets you stick to the, you can say, the developer mindset. Probably it's more developer oriented. Most of the people are basically not a great fan of TDD, because what they think is like it is a very time consuming, number one. Number two is like in a team of, let's suppose, a bigger size team, it's very difficult to moderate, or probably it's very difficult to enhance the same knowledge experience of TDD. But how I take it is basically TDD is nothing, has nothing to do with you can say architecture, I would say. So TDD will just give you a boost, right? You give you a boost, and that boost is something that will help you to think in that mindset. So let me share you one. Yeah, so this is one of the code by a Realm developer. So what he says is like, I really like this approach of testing. It just walks you through what's the next step I have to do to get this working. So in here, like, you will never find any TDD or development or something like that. So it's all about deciding the next step, right? So if you know that, yeah, this is gonna be my next step, it's fine. But if you don't know, TDD can help you, or test your test can guide you through the development and probably makes that happen. And you will find a better way, or probably you will find the next step in a very fast manner as you get the feedback, because testing is something that gives you a continuous feedback loop. Now coming back to here, so TDD, how the TDD, for all those who are unaware of TDD, so TDD is something we call it the red green refactor. So it starts with red. So let me jump over to a problem. So it's a kind of small demo, I would say. And for the sake of time, let's be specific. So what we have is like a problem statement where we say we have a given. So probably you can do this in a Dojo Kata as well. So I will tell you how you can have it in a TDD fashion. So there is a number 1 to n, and what the problem statement says, if the number is divisible by 3, you return fizz. It's a very fizz based problem. You will find lots of pair programming, lots of TDD examples on this over the net. And if the number is divisible by 5, return buzz. If the number is divisible by 3 and 5, then return fizz buzz. And if the number is neither divisible by both, return the number itself. Now how to approach, like for all those new, how to approach? So this is how I name my test, right? So I have a class, and that's it. So for the sake of this, so let's call it uh, let's do like this. Just a second. Yeah. So I'll create a new class. Okay. So let's call it demo should, or probably let's call it, because I need to be specific, so fizzbuzz should. So what is happening? Anyways, yeah, so this is something that we have now. My personal favorite is basically whenever you write your test case, you should write in a declarative manner, right? What should do. So let's suppose my input is 1, then it should return 1. Now my favorite is basically starting from bottom to the up. Now what I want is, I want an expected value 1 when, let's suppose I want a phase buzz demo, right? I want some class, and in from the class, or probably I will do like this. So let's suppose assert 1, I want actual 1, right? I want 1 when it says 1, because 1 is neither divisible by 3 nor 5, so it should return the number. Now what happens is, like, assert, I know I want to have 1. So when I can expect this, so let's suppose I say some class, some variable. So let's suppose I call it output. So this should be output, and this output, now when I run a test, it should give me a feedback, right? So this is output. Okay, now I need the output. So now I go upwards. Output. Okay, so let's have a output. Now from where I will get this? So since our class is fizz buzz, let's suppose I have a class. I again run this test, still red, my it's in read zone. So now I need to define a class. Now let's glow and define a class, fizz buzz, right? Run the code, it's green. Oh, sorry, what is it? Yeah. So now what happens? My output says output is fizzbuzz, but I am expecting this. Okay, now I need to call some function. So let's suppose off. I made a function. Now it shows red again. Now what I do, I create. Let's suppose I keep it string off. I don't do anything. Let's suppose I don't do anything. Now fizzbuzz off. Now fizzbuzz off is not returning anything. Let's do nothing. I'm not doing anything. Now what it says is, again, so it's returning null. Okay, now I go, yeah, it's saying I am expecting 1, but it's showing me null. Now okay, so what I'll be doing is, let's suppose off. Okay, now for the sake of this, I return 1. Now again, so this off is returning me 1. Now let's suppose I suppose this. So let's suppose it should return the number itself, right? Now I go run the test. Now it's pass. Now my problem is not complete, like, but still it is giving me a right output. I will stick to this. Now I would say 2. So 2 should be, whenever I pass 1, it should return me 1. So let's suppose num int, right? Now,
You created the class in the Java, I guess. That's why you're getting a little confused.
okay, yeah, I'll convert it to Kotlin, yeah, not a
Yeah.
problem. Yeah,
Command Option Shift K.
yeah, I'll do that. This was, and okay, so let's remove this. Okay, so now I have a physical class, and I will create a method this. Okay, so it's calling string num. Okay, now, so right now what I say is return 1, right? Now, okay, so now my method will say, yeah, so this is fails, right? Now I'm getting a pattern, right? So whenever I'm sending a particular fees buzz of, let's suppose I copy it here and do this. If I say fees buzz of this, so this is my when part now. So fees buzz of 2 should return 2, right? Now what happens is, like, it is showing me 1. Now I go there. Now I'm getting a pattern. So it's like, if num equal to 1, return 1, else let's suppose I call it 2. Now I go there, I run my test pass. Now let's increment. I go 3. What it should return? It should return, if I pass 3, it should return me fizz as per my requirement. I run the test, it fails. Now it says it's returned me 2, but it should be 3. I go there. What I do is, now I know that, yeah, if the number is 1, then return 1. Now I need another statement that says num divided by 3 equal to 0, then return fizz, right? So now what I can do is, so here, if number divisible by 3 is not equal to 0, and then return the norm itself, and for this sake I'll do this, and whenever this, and probably else let's put else return, let's suppose the number, right? Now I go there and run this, my code runs. Now again I go this. So what happens? It will return 4. So as you can see, what I am doing is, I am gathering my test cases. Like, whenever I'm incrementally adding one test case, let's suppose fees of 1, fees of 2, fees of 3. This could be perhaps different test cases, but for the sake of demo, I have put it in a single test cases. This could be different test cases for sure. So what it will do is, whenever you are incrementally adding your feature, what you're doing is, you are going back to your code, you are making only that sufficient change so that your test case pass, right? So what is the learning behind this? That your test case is basically driving your development, and while you are developing, while you are writing the test, you are basically writing and approaching towards the problem statement. Now, there is a crux. Do you think this is helping us to architect something, or probably making the decision, yes, this should be my best architecture, or probably this is the way how I need to go through? Definitely not. So what happens is, let me get you back to the TDD now. So what happens is, whenever there is a red test cases, you go to your code, write just enough code to pass the test, come back, see, yes, now it's green, now it's the time where you refactor. And this is the point where your design comes. Like, there you will see how you can optimize, how you can use your skills, your tools, to basically clean up and add the new functionality, and with confidence as in, because your test case is supported. Because whenever you will be doing a refactor, obviously it will be either red or green. So if it is a green, that means your code is working perfectly. But for those set of test cases, whenever you add a new set of test cases, probably it can fail again and go to the red zone. So this is how your TDD happens. There is one more term called behavior driven development, that is basically a superset of TDD, where you basically test the entire feedback loop that is coming from the customer. You revalidate the requirement, and probably you go and test your individual models. So there is various process to it as well. So this is how your TDD happens. And TDD can help you in writing the sufficient code that you require only for that particular problem statement. Remember the Yagni, case, and dry. So TD is primary for developers tool. It will help to create well-written unit of code, function, class, or module that correctly performs a set of operations. So this is how your TDD performs. So always remember, if there is a given problem statement, what basically when and then. So ideally the TDD says go from bottom to top. So if first of all you write your asserts thing, then you go to the class, then you say, yeah, then start giving inputs to your class. Start giving inputs, go to your class, refactor, again come back, run your code, and check whether your code is running properly. So this is something that TDD is all about. There is a famous quote from Sandro Mancuso. So he is one of the software craftsmen who basically founded the London software craftsman community. So right now, like what he says, so I was reading a book called Professional Pragmatism and Pride. So if you want to develop software with pride and professionalism, love what you do and do it with excellence, and build a career with autonomy, mastery, and purpose, it starts with the recognition that you are a craftsman. So whenever you feel good at that, yeah, you have developed a software with autonomy, mastery, and purpose, and also with excellence, applying all those principles, all those manifestos, and then you can recognize yourself as a craftsman. Once you embrace this powerful mindset, you can achieve unprecedented levels of technical excellence and customer satisfaction. So all this eventually results, all the software craftsmanship manifestos and all this stuff ultimately deals with customer satisfaction, not in terms of a single project delivery, but also the incremental project delivery, how easily or how fast you can deliver the next iteration. That is all about, having the technical excellence on that, how you can maintain your code. So these are some of the references where you will find a lot more about the movement, and also about the software craftsmanship tools and practices, and also the terms associated with. Thank you. And this is me. So I am trying to adapt to that movement, and thought of sharing a bit and pieces of software craftsmanship to all those who are very much new to this, and also refresh the theory to all those practitioners of software craftsmanship. You can connect me over all the mediums. I am in like LinkedIn, Twitter, anywhere. And basically currently I'm leading the Android guild at OLX. And this is all about me. You can reach me to any questions. Now I think we can open questions for the house.
So there is one question. Yeah, which books do you suggest for the software craftsmanship?
Okay, so the one that I mentioned, there is a book, Software Craftsmanship by Sandro Mancuso. that is already in my slides. Probably you can go and get a copy of it. It is basically a novel of software craftsmanship. So where you can learn all those nitty gritties about software craftsmanship movement and where it came from and how you can help yourself towards achieving that level. Yeah. So that is one book. Second, there is one book, Software Craftsmanship by Pete McBrand. That book you can get a copy. And but yeah, I would say go for the Sandro Mancuso first because he is very active person in his community of software craftsmanship, and yeah, you will definitely learn a lot of amount of it from that. So Kushal is having a question.
Hi, Hitesh. That was
Hi
really
Kushal.
an amazing session.
Thanks.
So, yeah, one question I have, like in my previous company, there is a very small startup company in Pune. So they basically don't following kind of the things you are discussed, like the solid principles or like the architecture patterns. They are following the Viper pattern. That is good, but apart from that, the because that when I joined that company, they are supposed to like, okay, Kushal, you have to stable this app within a month, and we have to like give the delivery to the client,
Mm-hmm.
and it will already get delayed, and the last developer like quit the job and all. So the context is that, or like my concern is that like uh, the the person who is the CEO of the company, he's a like senior Android developer, but yeah, he don't have an iOS experience, but he also not able to understand the importance of this design pattern or TDD or
Mm-hmm.
the
Mm-hmm.
solid principle, and they
Yeah.
are just like, okay, Kushal, do build up the feature, fix the bugs as early as possible. Don't worry about the raw code or like uh, just give the client delivery. That's it. So because of all this, like okay, I complete the features, I fix the bugs, but the app is more unstable, and it takes lot more time to fix the or the stable the app. So how
Okay.
we can convince this kind of scenarios to our senior managers or CEOs that this is really important. It's not like
Hmm.
that you give the client and just forget it. So
Yeah, thanks, Kushal. I think this is one of the top question that I used to receive. I was wondering that why this question didn't came up in this session because I have delivered this session almost like twice in two communities, and this question is something that is at the top every time. So how to convince, even like when I was attending one of the craftsmanship lectures, probably session, these questions came to my mind, like how to convince, because in agile, as I told you, in agile what is called agile environment, what happens is like we ideally shift from excellence, as you told, and towards the delivery thing, right? Mediocrity. So we choose a path where we are delivery oriented, and then we see that, yeah, then you can see, like even if you have delivered that to the customer. So customer happiness, as I told you, so customer happiness basically it is not one time. So what happens is like you delivered a particular product on a particular time, the customer is happy. It doesn't means that the customer will be happy with you throughout. So second time you give any iteration of release to the basically the customer will tell you that, yeah, the previous delivery was working fine, now you have added this feature, but the last, I have lost all my credentials. So this kind of things happens, and now you can't make for this particular excuse. You cannot excuse that, yeah, last time I have done a very great job, or why are you not happy this time? So this is all because of your foundation. So this is something that your management should be understanding. Like what happens is like, I was reading one of the talks by Sandro Mancuso, that book that I mentioned. So in there, like he was asked the similar question, like how to convince the upper management. So what he told is like, if you have some practice already well known and well established, as I told you, solid, agni, dry, and all this stuff, then what benefits are you getting out of it now without applying those, and after applying those, right? So if the person is totally unaware of it, then I think it will be very much difficult for you to make him understand, number one, right? Number two, if you think that yes, you have the capability or the bandwidth to incrementally change that, let's suppose, don't change the entire system, take a piece of code, right? Take a class where you find that, yeah, there is a lot of bugs in that particular class, refactor it, apply your best principle, take your time, probably an hour more, And what you do is like just narrate him, yeah, after I refactor, the number of bugs for that particular class have reduced. So what happens in this case is like you have some data as in that class behavior before applying your best practices and after applying the best practices. So let me tell you one example. Like in OLX app, our crash free users are 99.8. So initially, like, we struggled from 99.3, 99.6, 99.7. Then we strictly followed architectural patterns like proper testing, coverage, and all this stuff. Now our code is almost like 99.8% crash free users. Now this kind of figures, we can easily ask for the management. Yeah, last time we applied this particular pattern and this has reduced our bugs to a lot of extent. So therein you have that bandwidth, and therein they are bound to say, yeah, come on, Kushal, go and refactor the next bit and pieces. So but you should go baby steps at the very start, because you should know whom you are dealing with, and probably that guy is very much well acquainted with all those practices. If he doesn't convince, then there are obviously pet projects,
Yeah,
you
got it.
can apply them.
Yeah.
Yeah.
Yeah. Thank you so much, Hitesh.
Yeah.
I think it's part of like every organization when it starts, they don't know about the best practices,
Right.
and eventually, like when they grow up and they get like bigger, then they realize the importance of the software principles and how to go about development. So
Right.
yeah, I feel like the place where I'm working, which is the Dunzo app. So we have two different apps, which is one is the user app and one is the partner app.
Mm-hmm.
So both were developed like differently, like on different times. So the newer partner, the user app is like more inclined towards software like principles, and it includes all the TDD and everything. But the partner app was not. So we are so the same like DCFU rate of the
Mm.
partner app was around, I would say, 88%, and the user
Okay.
app was always above like 98%. So now uh, we formed a team and we got a whole quarter just to refactor the app and
Great.
build like build everything from architecture perspective, and we are using the same MVVM with
Right.
clean architecture and
Mm.
use including use cases and everything.
Right.
Along with that, we also included unit test casings. So now, like we grew from 88% to 98%, and we are competing with the
Nice.
user app. And yeah, this requires the upper management to listen, and how we can make them listen is, yeah, like they can see the difference between the data, and yeah, that's the
Mm.
whole point. Like they could see
Yes.
that this app is crashing more, that app is crashing a lot less. Why so they're the so yeah, like
And
our
also, yeah, so Sarthak, I think also one thing I want to mention, like earlier, what happened was, if you don't have a clean architecture and separation of concern,
hmm,
even if you don't have that kind of data with you, also you can easily judge from the fact that while solving a particular bug, right?
hmm,
So what happens is like whenever a production bug comes, what is the turnaround time?
yeah, yeah, yeah,
So if let's suppose without an architecture, I am 110% sure that it's gonna take more time than a fully
of
architect
course,
application, right?
yes.
So these data are very much essential when you are approaching towards it, and you need to convince someone at the front.
Yeah. Since we are, if you talk about separation of concern, like, so in an order management system, if your cart is not working, you know where the
Right.
classes are, where the
Right.
this function is called, where you are getting stuck, and which particular class and function is responsible for handling that particular. So separation of concern is a big thing, like I would say. And yeah, like we should always have a separation of concern, follow the solid principles. Yeah.
Right.
Yeah. Cool. So I don't think so there are any more questions. So
Okay.
yeah, we'll be signing off, and good luck to all the attendees to convince their managers on implementing software principles in their software development craftsmanship principles in their companies. And yeah, good luck and have a great day.
Yeah.
Thank you, Hitesh, once again for sharing your wisdom with us. And
My pleasure.
Yeah.
Yep.
All right.
Yes.
Thank you, guys.
Yep.